Hello everyone, I am Salman Ibn Yunus. I am back with another video, and this time this will be a live show, and today I will talk about classification. This is the continuation of my playlist series of machine learning tutorial series. So in my previous video I talked about regression and machine learning in general. So in today's video I will mainly I will talk about using supervised learning for classification. So we will learn how to classify So first of all, we need to know what is classification. So classification is about classifying two different objects. So that is putting them into two different classes. So in our previous example we have studied regression. So if you have watched my previous video, you already know what regression is, but I still want to give some recap. So regression is about predicting a continuous value. So for example, prices of house, or even some kind of continuous value. So when we are predicting continuous value, we use regression, but when we are using discrete values, like whether it will be raining today or not, so in this kind of examples, when we want to classify our into two different or more than two sets, then we will use classification. So today we will learn how to use k-nearest neighbor or KNN using scikitlearn. So stay with me through the whole video to learn more about k-nearest neighbor classification. So k-nearest neighbor is quite simple and easy to understand. So it is used in many applications such as finance, healthcare, science, image recognition, etc. So KNN is often also used for regression. So we will mainly use KNN classifier in our example. So first of all, let us know some of the concept of k-nearest neighbor and how it works. So here in KNN, k is the number of nearest neighbors. So here the number of neighbors is the main term here. So k is generally as an odd number if the number of classes is 2. When k equals to 1, then the algorithm is known as the nearest neighbor algorithm, which is the simple case. So if we have a point named p1, then our main objective is to find the closest point to p1 and then label the nearest point. So we find the number of closest points to p1 and then classify them by voting. Some kind of voting system is there. So the neighbor which gets the majority voting is classified as the neighbor of the point p1. Each object votes for their class, and the class with the most vote is taken as the prediction. So to find the closest similar points, the mostly used distance measures such as Euclidean distance, Hamming distance, Manhattan distance, etc. So this basic steps which knn or k nearest neighbor follows are such: number one, it calculates the distance between the neighbors, and then it finds the closest neighbor, and then it vote for the labels. So the labels which get the majority vote is classified as the neighbor of that class. So actually this is the main concept behind the k nearest neighbor algorithm. So let's take a look at some of the example coding. So let's try out some code from the scikitlearn. So first of all, we will use a wine dataset for classification of good quality or bad quality wines. So first of all, we'll have to import the library for dataset from scikitlearn. So write from scikitlearn import datasets. So for those who don't know yet, so we are using Google Colab from our last video, so you can use it online. So today I'm also using Google Colab Jupyter Notebooks. So now we can load the dataset. So let's name the variable wine, and then datasets dot load score. So this is the method which you need to call to get the dataset from scikitlearn datasets. So this code set is working. So now what we can do, we can actually exploit the data. So this was the part for like importing, and should add some comments or to better understand the code. So this first loads the data, and then we can exploit the data. So often we can use like pandas to exploit the data, or we can use like scikitlearn. So if we use pandas, we can import pandas as pd. But in this case we will not use pandas because we are using scikitlearn. But in most cases we use pandas for CSV or Excel datasets. So first of all, we can print the name of the features. So let's print name of features. So we can convert this cell into text cell actually. Okay, anyways, or so in this way we can write it explorer. So this is not a code cell, this is a text cell. So okay, let's do the code. So we can use a print statement to find the dataset features. So if we use this one we can get our features. So these are our features. So we have alcohol, malic acid content, and then alkalinity of has this type of features, color intensity, hue, proline. So these are probably some content of amino acid and different types of acids available in this dataset. So these are our features mainly. So since we are using a dataset from scikitlearn, so this is arranged in a good way, so we can like visualize the features and the levels in a easy way. Feature and also the target variable we can visualize with this code wine.target_name. But normally when we are not using scikitlearn dataset, so we have to do this process on our own. Like we need to split our dataset, and then we need to find the features and then store them in X variable and then target as Y. We need to do those steps manually, but here since we're using scikitlearn dataset, so this has already been done for us. So now we can see that we have 3 possible target or labels: class 0, class 1, class 2. So we will know more about the classes. So we also need to study a bit about the dataset. So this is the first step, is getting idea about the wine quality, about the dataset, or domain knowledge. So this is the information of the dataset that you will get in UCI machine learning repository. So this is about wine quality. So here you can see, the attribute information: fixed acidity, volatile acidity, pH, alcohol. This kind of informations are there. So probably we'll get in scikitlearn. So there you can see there are 3 classes. So there, like as you have seen, there are like 13 features. So here dimension is 13. So you can get the information about the dataset in this way. Also, there is a link provided here for downloading the dataset. So let's see the code more. So actually the dataset has 3 classes, as we have seen. So if we talk more about the dataset, so this is quite famous multi-class classification problem, because there are 3 classes. So it has, as I said, it has 13 features and 3 types of classes. So we will try to build a model to predict the classes from those features. So each of these classes have different characteristics. Let's dive more into the data, or take a look at the feature set. So if we print statement and then we write wine.data, so this will give us the top 5 data from the so this is in this format, and this is the top 5 data. So this is not, we don't get much information here from here, or not quite understandable. So let's check again. Wine.target. So these are the target, like these are the 0 classes, 1 class and 2 classes. So let's explore more. Let's write print statement again, and actually it should work even without the print statement. For shape, let's see, yeah, it's working without the print statement. So there are 178 rows in this data set and 13 columns. That's 13 features. So this was the shape of the whole data set, but we can also print the shape of the target variable only as well. So now let's split the data and understand the model performance. So to understand the model performance, we will divide the data set into training and test set. So to split the data set into train and test, we'll have to write this line of code. So let's create a heading for it at first. So let's write it train test split. So first of all, for this line of code, we'll have to import the train test split function from scikitlearn. So from scikitlearn dot model underscore selection import train underscore test underscore split. Yeah, so you can see their suggestion is also shown here, so this is the right one. So let's split the data set to train and test set. So these are pretty basic stuffs of machine learning using scikitlearn and Python, so most of you might already know. So this series and these videos are for absolute beginners. So this will be quite helpful for beginners. So then we have to write train underscore test. So you can see the suggestion. So we will first, inside the function, we will pass 3 parameters. So number 1 is wine.data, so the whole data set. and then we will use window target for the labels, and then we will split the test size. So we will use the 20% of the data for testing purposes to validate our model later. So to validate the performance of a model. So now we will, so since our dataset is now split, so you can check it. So if I give x underscore train, you can see that now you will get a separate training variable, and also for testing purpose you will also you can print the y underscore train. So this should keep the labels. Yeah, as you can see, this is giving the labels. So now we will build our model. So KNN classifier will be built. So let's see how to build a KNN classifier. I think this will be quite helpful for you. So we'll have to first import scikitlearn neighbors classifier model from scikitlearn. So we'll try it from scikitlearn dot neighbors import k neighbors. I will try to share the code after the live and in the discussion. So from now on I will try to do live sessions regularly. Then we'll create a KNN classifier. So let's set a variable KNN equals to k neighbors classifier. So here we will have to set the k value. So we can initially set the k value to say 5. So if we choose the 5 neighbors, so let's choose 5 neighbors. So this is like a tuning parameter, you can change it later. So then we will train the model. We will use the fit function to train. So as you know that in supervised learning, the model gets trained or gets supervised by the target variable. So in training we are showing the labels as well to the model. So I'm trying to go from pretty basic so that it becomes easier for you to understand. So then we will use ypret variable to predict using KNN. So for prediction we will use the features of the test slate. So let's run this line of this code. So if we now we can calculate the accuracy by comparing actual tested values and predicted values, that is y pred and y test. So let's see how we can compute the accuracy and by comparing the actual test values and predicted values. So for that we first have to import metrics from scikitlearn. So from scikitlearn import metrics. So we'll use a print statement. So we can use write accuracy like this to print. Then we can use matrix accuracy underscore score method from scikitlearn, and then we can pass y underscore test and y underscore pred in the method to compare. So let's run this code. So as you can see, this is shows around 72% of accuracy. So this is a good accuracy, but we can use different number of neighbors in our model to create a new model to improve the accuracy. So let's try another new model with new number of neighbors. So there can be more neighbors, but the neighbors which, as we have studied, that the neighbors which gets the most vote will be classified as the level or the class. So neighbor will choose the most voted point as the class. So let's see if taking more neighbors helps us or not. So let's take it 10 and then use again the predict and the method and the accuracy. Let's run the accuracy matrix. So it has actually decreased. So let's try a different value for neighbors. So this is like a hyperparameter tuning, so it's the same. So let's use 7. Yeah, it's slightly improved. So our numbers of neighbors seems to be working good. Let's see. No, not always. It's, you cannot take it as a rule, I guess. Yeah, so 7 works good, better. So probably let's increase. No, it's not working as good as 7. So this is the classification accuracy, and this is how we can carry out classification using k-nearest neighbors using scikitlearn. But there are some advantages and disadvantages of using k-nearest neighbor. So the advantages are like k-nearest neighbor is much faster compared to other classification algorithms. So in case of nonlinear data and even for regression problems, k-nearest neighbor could be helpful, but there are some disadvantages, like in testing phase, k-nearest neighbor is quite slower and costlier in terms of time and memory. It requires a lot of memory, and Also, KNN requires scaling of data as it uses Euclidean distance between two data points to find the nearest neighbor. Euclidean distance is sensitive to magnitudes. The features with high magnitudes will weigh more than the features with low magnitude. Also, KNN is not suitable for large dimensional data. So if we use normalization, then we might be able to improve the KNN results much better. So you can try normalization or scaling from scikitlearn to improve the data. So that's all from today's video. So we have seen how we can perform classification on wine quality data set. So we tried to predict the wine quality. So if we see the white bread, this predicts like this with a 75% accuracy. So that's all from today. See you in my next video when I will try to explain another concept of machine learning. That's all from today. Thank you for your time and understanding.